So, hey everyone, thanks for coming out. Thanks for attending. We, as engineers, usually need to build new things. So, I'm going to give all of you a task. This task is to build a really fancy profile UI. First time ever you're doing it, you've got this brand new shiny app. You're responsible for everything in it. So, we're here at the GraphQL conference. We're used to thinking in GraphQL, or we'll get better at it over the course of this conference. Well, when we think about what we need for this basic UI, we need some JSON response that has a picture and the information about the person you're viewing. So in my case, we can tell I'm clearly not a designer. Just like Dan. So given this app, we're going to need to scale it over time, assuming we're successful. So at the start, we'll probably just have one fragment. One person will be building this out. They'll understand the server. They'll understand the client. They'll know intimately what the code in PHP or Ruby or whatever your server's written in does in order to get a picture. They'll know intimately what the description is all about. And over time, as the app gets more and more success, as people start using it, we'll hire somebody else. All of a sudden, you're a tech lead. So you're responsible for making sure the app or the profile UI is really, really good. And somebody else on your team can take over the responsibility for imaging, for fetching images from a cache, for making sure that they can actually render the image consistently everywhere. I don't have to worry about that anymore. I'm the tech lead. And again, we scale again. Now we need to add more features into our app. We need some sort of, in addition to our profile, we also need to worry about other verticals like groups. So a group is very similar to a profile, except for instead of having an about, it has info, and that info might have tons of different information, but it might be a nested tree. In this case, we can see our example group is all about geese. And these different sections are going to want to share a lot of infrastructure, share a lot of components across the app. So if I'm building out a new group section, I don't want to have to worry about how do I fetch an image from our CDN? How do I render that? That should be somebody else's responsibility, somebody who's actually good at that. And over time, we'll scale again. So we've seen tons and tons of success, and now we've got people clamoring for us to build more and more apps. The unfortunate thing here, as from an engineering point of view, is that oftentimes this means each app has its own designer, which means in one app, the designer is saying, everything, every single image needs to be square. We have to have this consistent user experience. So every single image must be square. And in the second app we build, the designer's saying, well, that doesn't fit our original design pattern here. So in our second app, we need every single image to be round. So we need a way to describe, yeah, we're reusing a lot of the same pieces, but somewhere in that tree of information, we're actually going to end up with something slightly different. So I'm Matt Mahoney. I'm a software engineer at Facebook, and I'm here to talk about scaling your GraphQL client. So some of the things we're going to talk about today are models. How do we actually model this data? How do we get the models to scale with the size of our app, our organization, our company? So we'll talk about basic JSON models. We'll go into type models and how you can represent models from your schema. We'll go into response models. So given the tree that we're getting back from the server, how can we access that tree? And then we'll dive into fragment models. So how can we encapsulate just the data we need for specific components? And this really is the history of how Facebook has worked with our native clients to figure out how we're going to model our data, how we're going to access them in the apps. So the first thing you want to do is just use JSON. Like the spec says that your GraphQL server is going to return you JSON. This is great. Everybody knows how to deal with it, right? So if we look at this nice schema, we've got some user with an about and a picture. We've got an image. And we'll use some fragment to actually get the data we need for our profile UI. A JSON model basically just ignores all of that. We have getters that let us access by key. Usually, if we're in Java, there will be some third-party JSON parsing library that we can import. And then there will be some values on it that let us say, this key we're expecting a string from. This key is going to be another JSON object, etc. So this is actually a pretty good thing at the scale of one person early on in your app, because it's easy to iterate. The thing that you're taking in is just a library for JSON. And if we're going to use it, we just call the natural JSON getters that already exist in our JSON library. So to render that image, all we need to do is ask for it in JSON form and then get the URI out of it. But this is going to happen a lot. We have some issues. So one of the immediate ones is that we've got a typo. I forgot that we actually encoded the URL to be URL, not URI. And that's really hard to see, especially on my computer screen, but up here as well. What's the difference between an L and an I? And we don't really get any form of type safety. So we're getting this about as an integer. That makes no sense. From the server, it's going to be a string, and then our JSON is going to give us something, maybe. Maybe it'll coerce it. Maybe it'll crash. I don't know. And again, we've got this problem that I'm going to call underfetching. So we want to get the information so that we can render that I'm not a designer about information, but we never actually asked for it. If we don't ask for it, we're just going to get some null value instead of what we actually want. So underfetching means that we are using the data in our component, but we never got it from the server. And the corollary to underfetching is overfetching. So it's very easy, especially with JSON models, to ask for more data than you need. Some people want to, ask for more data because they might need it in the future, but every single field that we ask for is execution time on the server, and also, possibly more importantly, is data that we're costing our users. So if we can do anything to prevent asking for more data than we actually need, we probably should try. And JSON models, we don't really recommend at large scale. So we expect people using JSON models to own the schema, own the client, really own the whole code that they're working with. They should be having well-defined stable types. It's not a lot of iteration. And at Facebook, we do use JSON models quite frequently, but usually it's in the form of things like tooling or tests, things that when we change how they work, get run in automation or will immediately fine. We don't want things that when we change will lead to bugs in production. So if we're not going to use JSON models, maybe we can generate something that has getters will prevent these typo bugs, will give us better type information. The obvious thing to do is to use type models. And the basis of type models is the schema that we generate. So you've written up your server resolvers, you've got all the fields that you can possibly access, and these fields then produce the SDL. We can use these to generate Java classes in the case of Android, or iOS or Objective-C classes for iOS, and provide getters for each field on the type. This is just a one-to-one mapping. If the field is nullable in the schema, it'll be nullable as a getter. If we try to fetch it, maybe it won't actually be there. That's OK. So this does scale pretty well to like about one team. Over time, though, so doing it directly on the schema, we hit a problem very, very quickly. And that's we can't even alias fields. So I, as the tech lead, assigned somebody else to create the image, and they decided, well, this is a square picture, but the picture's really little for the profile, so we're just going to name it LilPic. There's no way to represent that. I have no way to get that picture, and I can't tell whether I'm getting that little picture or big picture just from the model itself. So we need to do something a little bit different. At Facebook also, this just wouldn't scale. We have 30,000 types in our schema and 200,000 fields. If every single Facebook app had to take in that entire schema, 30,000 additional classes shipped with our Android app, that would be completely ridiculous. Like we'd be wasting people's data before they even open the app. So instead of having the type models be based directly on the query or based on the schema itself, we can base it off of what we actually ask for in the scope of the app. So in this case, we generate much smaller type models that have a one-to-one mapping with what we asked for. If we have an alias, we get it. But if we have fields that came from somewhere else, some other query unrelated to my profile component, I'm going to get those in my type model as well. So to use it, you just pass around your user model, your image model, pass it around throughout the app. To render the picture, we can just have an interface has pic model that, so long as we implement, we will be able to pass down into that renderer. So this is great. We now no longer get typos. And we get type safety, right? Because you can't act like the fields that you're going to get, if it says it's a string in your schema, you're going to get it as a string. But that's not totally true. What do I mean by this? So there are instances in the GraphQL spec when even though something says it cannot be nullable, it can end up being null in your response. Type models, because they work on the scale of the entire app, have no way of differentiating those two states. You have to choose one, even though in one response it is non-nullable, in the other it could be nullable, which means when I try to access my URL, I don't actually render anything. So we still also have the underfetching problem. I didn't point it out, and you probably didn't notice, this is something I probably wouldn't have noticed, but we never actually are asking for the image fields. Even though the type that we have, the user model, has that LilPic field available on it, we only are asking for the about field, and when we try to access them, they'll be null, and in this case, we assumed that the image was non-null, and we'll probably get a null pointer exception and crash the app. And again, we still can't really solve overfetching. If I delete the big picture here, I'm not using it directly in my component, but somebody else might be using it, and I have no idea who that is. Every time I delete some field, I have to go through and hunt through the entire app and find every usage of it in order to remove all that code to allow the app to even build, even though nobody else was ever actually fetching that field. So type models also don't scale well to many teams because you have to choose, do I have one gigantic type model library, or do I have a type model library, per team? How do I mix and match this? You have to make a choice, and any choice is basically not great. And again, I talked about builds breaking. Any change you make to type models can affect some other team's code. You have to rebuild that code, otherwise their build is broken without you knowing. This does scale. This scales actually quite far. I wouldn't recommend scaling it that far, but Facebook still uses type models quite frequently. The models scale with how widely used they are in the app. But to keep it correct, it requires a lot of manual testing because you can delete a field and not know what the downstream effects are on all the other queries in your app. So we know we don't want to use type models. What can we do? Well, there's another kind of model called a response model. The core idea here is that GraphQL responses form a tree. They form a tree of information, and we want to ensure that we have access to all the pieces in that tree of information. So for response models, we create one class or one interface per fragment. We use interface inheritance to represent fragment spreads. So the user profile has access to little pic because it extends square pic. And little pic, so square pic.little pic, has access to the URL field because it extends core image. This allows us to scale the app to many more teams because we know that the data that I have access to is only what I've actually asked for. When we're using it to pass some response model into another function, so I've got some profile and I want to render the square picture of that profile, I just get my model and pass it down. Because I used interface inheritance, I know that I am a square pic. This leads to a really nice property. With response models, it becomes impossible to underfetch. If you don't ask for the data you need, it won't be there in your response model. If you don't spread all the fragments for all the information that you actually use, it'll be a build time, compile time error. But we still don't solve overfetch. Again, we've got this big pic here. We're asking for way too much data that we don't really need. This other person on my team just did not get the brief, didn't realize that he never needed to ask for it. But because we're not encapsulated, we can still cause problems in the app when we remove important fields. So in this example, we're removing the URL from the core image. The core image component, the team responsible for rendering images, caching them, getting them from the CDNs decided URLs by themselves aren't what they need to render an image. Instead, they need some smart URL, they need more information or different information. Well, unfortunately for that core image team, every team in the entire app has started to depend on them because they're the source of truth. And other teams have started to do funky things with that URL that's part of core image. No other team's fragment includes URL, but because the response model gives you access to everything via inheritance, they're using it. and they're making product decisions based on it. So when the core image team removes the URL, all of a sudden, products start breaking throughout the app. That core image team now needs to go to every single product that uses their code and fix it up. This greatly slows down infrastructure teams. If you ever have somebody relying on your code, this is not a great state to be in. At Facebook, it has led to situations where modifying a core fragment that's used everywhere in the app has led to hour-long builds. Nobody wants that, and so we need some other way of doing it. Additionally, response models they scale really well in one application, but if we have two applications and we've got the two designers, so remember we had one designer say all our images need to be square, and we've got another designer that says all our images need to be round, there's no way to encode that besides maybe overfetching. Maybe we fetch both pictures, and at runtime, we decide based on the context what to do. It'd be a lot nicer if we could use only that data we actually need for the app that we're running. We don't want to pull in information from the Squares app just so that it can share the core image component with the Circles app. So these response models do scale. For our Facebook native clients, we quickly learned that type models were problematic. We quickly moved to this response model view of the world. And most of our models at Facebook today in our native clients, so iOS and Android, are these response models. So we want something more encapsulated, more modular, something that can really scale not just with one application, but across many. Because, again, our company has been so successful that we now have shared infrastructure across applications. Bring in the fragment model. So a fragment model is very similar to a response model, except every fragment that you spread acts as a black box. Instead of using interface inheritance, instead of getting the fields implicitly because somebody else called them, to pass yourself to a function expecting a different fragment, you need to do an explicit conversion of some form. So in order to pass my user profile with the fragment that I spread into the picture rendering method, I need to do the conversion. I need to say .as that app pic. So this, in our view, does actually scale very well to many apps. As an example of usage, you can convert yourself between fragments, and one nice property that this allows that is a little bit more correct actually than response models is your fragments that you convert to can end up being null. So the core image had an @include if. If we didn't actually ask for the data from core image, well, why are we trying to render that component? We should only be rendering the core image component if we actually got that data back in our response. This allows us to do fun things like if you're getting a union of types and you're spreading a bunch of concrete types, you can ask, OK, am I this concrete type? No, render something else. This isn't easily possible with response models. So we've solved typos, we solved type safety, we still have underfetching solved, but it's still possible to overfetch. We still haven't statically at build time prevented you from overfetching. But because we're well encapsulated, because you can't access any child fields, in code review, when I see somebody has their GraphQL fragment has a field they're not using in their component, they can delete it because we know it's not going to affect anyone else. Every other product in the app is using my fragment as a black box. This drives down our build times. So instead of being big O, all the queries that use the core image fragment, it's now just the core image library that needs to be rebuilt when I modify that fragment. Because we can safely delete fields, we reduce our overfetching even if we can't statically eliminate it purely through the models themselves. Fragment models also scale pretty well to many apps. If each app has its own design team, we still, as engineers, usually want to reuse the core components. Because the models are black boxes, because we enforced encapsulation, we can inject app-specific fragments based on the context that they're running in to match the design or the needs in a specific application or context. And generally, at Facebook, we have not found pure true fragment models to have major scaling problems. They add overhead. They're more complex to generate than raw JSON or type models or even response models, which is why our natural inclination was to build up those other kinds of models first. But we found first through iteration, actually through Relay. Relay was built from the ground up with this idea of using fragment models first. They learned from many of the mistakes that we'd already made in our native code and are still trying to unwind in Facebook's core applications, where Relay always used fragment models. And in our native code, in Objective-C and Java, we're starting to do that massive migration. We're starting to try to move the mountain to move us away from our type models and response models to true fragment models.